Dear students, welcome back. In the previous lesson, we were talking about the introduction of organic chemistry, basic terminologies in that. Today, we are going to start with the topic alkanes. The general formula of alkanes is CnH2n plus 2, mean if the hydrogen number, carbon number is 2, then hydrogen number will be 6. By putting, N as 2, for example, you see if carbon number is if carbon number is 2, hydrogen number will be double of carbon, mean that is 4 plus 2. It will be C2H6. Similarly, if carbon number is 3, H will be 3 2s are 6 plus 2 will give us 8. This is propane, this is ethane, this is the general formula for the making molecular formula of alkanes. Okay, hope you understand. Now, see, the first member is methane. The structure is CH4. It has one carbon. Its molecular formula is CH4. Don't mix structural formula with molecular formula. Molecular formula shows the number of atoms in that compound, while the structure shows all the bonds in that compound. Similarly, ethane has two carbons. Molecular formula is this one, structure is this one, and so on. Hope you understand. If you have any problem, you can comment in my comment box, and inshallah, I will be helping you. Let's move to the next slide. What is there? In the next slide, we will be talking about physical properties and then chemical properties. Now that is the isomers and their structures and naming of them. Let's move to the next slide. Yes. Now we are talking about physical properties of alkanes. Uh, as you know, in chemical bonding, you might have studied that covalent compounds are usually insoluble in water. As alkanes, they are also in covalent compounds. They are also insoluble in water. They have low melting and boiling points. When we say they have low melting and boiling points, that means they have weak intermolecular forces. As we go down the homologous series, what happens? The boiling point, melting and boiling points increases down the series because of increase in intermolecular forces. Although they are weak intermolecular forces, but with the increase in carbon number in their chains, the intermolecular forces go on increasing. That is why first four carbons, first four members, C1 to C4, they are gases, and C5 till C16, they are liquids. After C17 onward, they are solids. This is due to increase in intermolecular forces. At the same time, they are volatile. Volatile mean they can easily evaporate if they are left open in the atmosphere. They can, for example, the components of petrol, they can easily evaporate. Volatility decreases. Why it, why it decreases? Because the intermolecular forces become strong and it becomes difficult for the molecules to escape. But still, we will call them as volatile. Hope you understand. Let's move to the next slide. Now, chemical properties. In chemical properties, make sure this, chemical properties of alkanes are very important because they are usually asked in the examination. So the first chemical property of alkanes is combustion. Let's talk about combustion first. Basically, combustion is the burning of fuel of alkanes. Alkanes are fuels. So when we burn alkanes in excess, uh, supply of oxygen, mean air. So why I underline this one? In CAIE, examiner expects from students underline the main, central idea in the answer. The factor, yeah, or the word which is more important has impact on the concept. You have to you better to underline that one. This will be good for you. Okay. So when alkanes are burned in excess supply of air, they form carbon dioxide and steam only, along with the evolution of heat energy. For example, methane is the main component of natural gas. 95% of the natural gas is methane, which when burned in excess supply of oxygen or air, a lot of energy will be released. That energy can be used for different purposes in automobiles or in the domestic fuel as a domestic fuel. So let's see the chemical equation for the combustion of methane. This equation basically shows complete combustion of alkanes. When we have excess air, then methane, ethane, propane, butane, all the alkanes will burn completely, and they will produce carbon dioxide and steam. These are the products of complete combustion. Complete combustion needs excess air. Hope you understand. So, for example, this is methane, the first member of alkanes. When burns in oxygen in the air, it produces CO2, H2O. Along with this, heat energy is given off. This reaction is exothermic because the heat energy required to start a reaction to break the bonds of the reactants is less, while the energy released during bond formation of CO2 and H2O is more. That's why it is exothermic reaction and cause surrounding to get warm. This energy can be used for different purposes, as I already told you. Hope you understand. Similarly, you can go for methane, ethane, propane, butane. Please make equations of for first for five members and do their balancing, because balancing of combustion reaction of alkanes is very important. This is usually asked in the examination. Hope you understand. Yes. Butane is the fourth member. Butane has four carbon in it. Butane is C4H10. It is commonly used as camping gas called calor gas. Again, it burns to form carbon dioxide and steam in excess air. In excess air. So the products will be CO2 and H2O, same as methane, but the number of moles are different. So in this case, you see, while balancing, we have some problems. Sometimes we are unable to balance easily when there are even and odd number of atoms on both sides for a certain element. Then we can go for fraction. After fraction, we will balance it. When the balancing is done, you can multiply whole the equation to remove that fraction. You understand? Incomplete combustion. As along with complete combustion, there are chances of incomplete combustion. You might have seen in the homes where kitchens are usually closed. There is no proper ventilation. Uh, the walls, whatever is lying over there, it gets blackish due to the formation of carbon, which is also known as coke, and also releases carbon monoxide. Now let's see, when methane burns in limited air. Keep in mind, when we call incomplete combustion, then the air or oxygen is not in excess. It is limited. That is why the gas methane does not burn properly. And when it does not burn completely, it will be producing carbon monoxide in greater quantity, along with the formation of steam You can balance it 3.5. I have done this in fraction, but better you remove this decimal by putting 10 on it and multiplying by a factor so that decimal should not exist. Okay, hope you understand the difference between complete combustion and incomplete combustion. So incomplete combustion, the products are carbon monoxide, steam. Along with this, we have carbon as well. But we at this level, we don't write in equation. But if the question is, what are the possible products of combustion of alkanes, we will have to write four: carbon dioxide, carbon monoxide, steam, and carbon. Hope you understand. If you have any question, you can write in comment box. Please do subscribe my channel so that you can get more videos, almost all the videos of complete syllabus of O-level chemistry. Inshallah, I will be starting the lessons on A-levels chemistry soon. After I am going to finish almost half of this O-level chemistry. Fine. So with complete combustion and incomplete combustion. Hope you are clear with it. If you have still problem, you can discuss with me. You can send your message. I will satisfy you. And keep in mind, I am always available for you people to help. And I will, with the passage of time, I will tell you how to get good grades. Okay. If we are talking about substitution reaction of alkanes, then you see this is one of the most important reaction which is being asked in the examination. Make sure you get it easily. I will try to draw the structures as well so that you can understand properly. So students, there are different types of reactions, but over here we are talking about substitution reactions. The alkanes undergo substitution reaction because they are a saturated hydrocarbon. Right after this, we will be talking about in next video, uh, addition reaction that will be for alkenes wherever there are double covalent bond between carbon atoms. Hope you understand. So let's start with it. For example, we are talking about substitution reaction of methane. This is one of the most important reaction which is usually considered by the examiner during paper week. For example, when methane react with chlorine, what is produced? Chloromethane is produced. This is, and sorry, you may change it to N, chloromethane. So how this chloromethane is formed? Along with chloromethane, HCl gas is produced. This is not an acid, keep in mind. If somebody asks you what you will observe during this reaction, you can say white fumes because HCl gas is in the form of white fumes escape into the atmosphere. Now, how this reaction happened basically? Let's open it. Let's say this is CH4. The Cl2, we can write Cl2 like this. Show all the covalent bonds. First of all, the chlorine covalent bond will be broken. How it will be broken? By using UV light. Students, keep in mind, without UV light, this reaction cannot take place. In all the steps, we will be using UV light, ultraviolet light that is coming from sun. Okay. So in this case, first, when chlorine molecule is split into chlorine atoms, like say this one, and these atoms will be attacking on this bond, this bond will be broken and hydrogen will leave and it will join with this second chlorine atom. The first chlorine atom will be substituting hydrogen and making a covalent bond with carbon. For example, it will be like this, the Cl. So this Cl has been substituted for hydrogen in methane, this one. The hydrogen which have been removed from here, from the methane, this one will be combining with Cl, which is coming from Cl2, and it will be producing HCl. You understand, this HCl is coming by the reaction of methane and chlorine. This reaction needs UV light, sunlight energy is required to carry out this substitution reaction. Now, the main product is chloromethane. This will be known as byproduct. Don't consider it as product. Keep in mind, in the paper, they will say you write down equation showing the two products. What the student do, they usually make one equation and say that this is first product, this is second product. No, you will get only 1 mark. It carries 2 marks. So you have to write 2 steps. One and hope up till now you are clear with it. Now, see, this chloromethane, which is formed in the first step, will be reacting further with chlorine. And similarly, as in the first step, one hydrogen atom was replaced with the chlorine atom, and we got chloromethane and byproduct as HCl fumes. Okay. So now this product, which is chloromethane, will further react with chlorine to make dichloromethane. Now two hydrogen atoms have been replaced. This reaction will remain continuous until all the hydrogen of the methane gas will be replaced with Cl, means chlorine atoms from the chlorine. In order to continue this reaction, the availability of chlorine and UV light is very important. Without them, this reaction cannot proceed further. So again, we have HCl. HCl is formed just like this one. Okay, now this dichloromethane, why we call it di? Because there are two Cl. If you want to see the structure, this is Cl. So in every step, we will replace one hydrogen with chlorine atom. So you must keep in mind the 4 covalent bonds should be there every time. This okay, when dichloromethane is formed, then it will further react with this dichloromethane, will further react with chlorine to produce trichloromethane. Only one hydrogen is left here. In first step, one hydrogen was removed from methane. In second step, another hydrogen was removed from chloromethane. In third step, again one hydrogen was replaced. So we got trichloro, mean 3 trichloromethane here. Along with this, we have again byproduct HCl gas in the form of misty or white fumes. The last step, when we have only one hydrogen left, it will further react with chlorine. Now this hydrogen will also be replaced with Cl, and we will be having CCl4 instead of C. Here we have 4 hydrogen, here we have 4 chlorine atoms. So all the hydrogen atoms have been replaced with the halogen. Keep in mind, chlorine and bromine react with alkanes in the similar way, but the other, halogen, they usually don't react because their conditions are very high. Understand? This is chloromethane, this is dichloromethane, trichloromethane, this is tetrachloromethane. Tetra mean 4. Tetrachloromethane. Hope you understand. Uh, it is That's it for today. Inshallah, we will continue by making isomers of alkanes and their properties. And then after that, we will be starting with uh, alkenes. You understand? Thank you very much. Please do subscribe my channel. Thank you.